Okay, the last thing we're going to talk about is some tree diagrams and basically how to uh, draw them. Now notice, in this one it's a kidney transplant, 90% survive the transplant, 10% die. Transplant succeeds in 60% of those who survive, and others 40% must return to the kidney dialysis. The proportion who survive 5 years are 70% for those with a new kidney and 50% for those who return to dialysis. The question is, Morris wants to know the probability he will survive for the 5 years. Now, in stage one, that's the transplant. You're either going to survive or you're going to die. Now, as it says, 90% survive the transplant. So that's going to be step one. So hopefully you are paying attention here when I say this is step one, okay? This is step one. That's this right here. That's this section going straight up. So 0.9 and 0.1. Then, after, if the person dies on the operating table, we don't go any further. They're dead, you can't do anything. But if the person survives, that means stage two is whether or not it's a success. So, if you notice, transplant success, that's talking about stage two. That's this right here. All right? So, it's either going to work with 0.6, and if it doesn't work, they go back to dialysis. So, that's 0.4. Notice 60% of those who survive the transplant is a success. The 40% must return to kidney dialysis. So basically this is your second stage. And then finally you have a third stage. Okay, this third stage is survival of 5 years. Now, if you have a new kidney and you're a survivor, you've got a new kidney, and then you survive another 5 years, well, that's 0.7. All right, that's what it states right here. But then you also have the possibility of dying, because it says for those with a new kidney, 50% for those who return to dialysis. All right? Now, if you notice, this is the proportion who survive 5 years is 70%. So that's 70%. That means if someone dies, they have a 30% chance of dying. So that's 0.3. Now, notice this right here. If the person goes back to dialysis, this states that for those with a new kidney, they got the 70%, and it's 50% for those who return to dialysis. So if you have dialysis and you return to, you have a 50% chance of surviving. That means you have a 50% chance of dying. Now, with all that being said, let me go ahead and erase all these highlighted areas because we're going to need this real quick. All right, so now you have step 1, step 2, and step 3. Or sorry, stage 1, stage 2, and stage 3. All right, almost done here. All right. What we want to do, what we want to concentrate on is we want to know the probability. Morris wants to know the probability that he will survive for 5 years. So this is the question that we are trying to answer, this one right here. Well, if you notice, Morris is going to survive this route, and Morris is going to survive this route. So we have to find both those probabilities. This one is 0.9 times 0.6 times 0.7, which gives you a survival rate of 0.378. But he also survives with the dialysis machine, which is 0.9 times 0.4 times 0.5, which is 0.18. Well, what you end up doing is you take both of those probabilities and you add them together. And that gives you the probability of surviving for 5 years. All right, now let's talk about drug use. Let's talk about athletes and drug testing. 2% of the athletes had taken banned drugs in the 2008 Olympics. So we're going to use this information here in order to fill out the chart down here. So a false positive is a rate of 1%, and a false negative is a rate of 0.5%. What's the probability that an athlete who tested positive actually took drugs? So that's what we are commissioned to find out. So let's go ahead and I'm going to minimize this and get it out of the way. We'll keep that off to the side because we're still going to use that information to build the table or the diagram. All right, so let's look at this diagram. All right. Now, we're going to randomly choose an athlete. So notice, it said that 2% of the athletes took an illegal drug or a banned drug. So that's that 2% right there. That means 0.98 did not take anything. Now, that's your first stage. Took drugs, did not take drugs. Then they're going to be tested. Now, if a person took drugs, it's a chance that they will test positive for whatever drug, all right, or for a banned substance. Now, it did state that a false negative was 5%. Well, a false negative means they really did take drugs, but it showed up negative. So that's at 0.005. That means a positive would be 0.995 because those two things right here have to add up to 1. Now, let's say the person didn't take any drugs. That's the 0.98. Well, it did say that there's a 1% chance of them having a false positive. That's what this is right here. That's a false positive. That means that 0.99 of those who did not take it tested negative. All right, and you've got to filter all that through. Now, let's go ahead and look at this down here. This is what I want to get at. So let me go ahead and I'm going to highlight this real quick. Make sure that's all put together. I'm going to keep those highlighted areas. All right, let me go ahead and group that. All right, I'm going to group it, and then I'm going to minimize it. All right, there we go. Now, let's take a look at this. All right, we have two events. B took drugs, and A was test positive. So mathematically, this is what happens. Increase that. All right, so this is mathematically what happens. We want to know the probability that someone took drugs given that they tested positive. So we find out that someone tested positive. What's the probability that they did take drugs? Now notice, here's the formula. The probability of B given A is equal to the probability of A and B over the probability of A. So that's this formula right here, okay? Now, the probability of A and B is, let me pull this back up again. The probability of A and B happening is this little section right here, 0.02 times 0.995. That's what you put on top. Now, the probability of A, that means that they get positive test results. You've got to understand that there are two sections that they get a positive test result. Okay? That's this section right here and this section right here. All right? Both of those give you a positive test result. So what you have to do is find this product here and add it to the product here. And that's what we've done here on the denominator. Okay? And then basically it's just put in the calculator, 0.0199 divided by 0.027, and that's 0.67. That means 67% of all the athletes who tested positive actually took drugs. Okay? Kind of give you an idea of what the next page looks like. Basically, we took that information and we applied it in a two-way table. And finalized that. This is why we require two athletes to normally submit 2 urine or drug samples at each test.